Hey guys, hope you're all enjoying your day off. Let's look at this review sheet on the rate of change and the power rule. So in this first one, for number 3, let's rewrite it as y equals 2 times 5x plus 1 to the negative 3. That way we can use our power rule and then worry about the derivative of what's inside. So let's take this exponent here, negative 3 times 2, so y prime will be negative 6 times what was originally inside, and then if we subtract 1 from that exponent, we'll get negative 4. We then have to multiply by the derivative of what's inside, and the derivative of 5x plus 1 is 5. And then negative 6 times 5 is negative 30 times 5x plus 1 to the negative 4. So if we look at our answers, okay, here we have negative 30, but it's not to the negative 4. Negative 30 times 5x plus 1 to the negative 4. It may have also looked like it was e, except e was not negative, so even though we could move that into the denominator to make it positive, that leading coefficient still has to be negative. Okay, here. One of the ones that I suggested that we kind of put into our memory is that whenever we have the square root of something, the derivative is going to be 1 over 2 times the square root of that something minus 1. And then we have to multiply by the derivative of what was inside that radical, so times 2x plus 2. Now there is some cleaning up that we can do here, because if we look at this part, we could rewrite that as 2 times x plus 1 and then over 2 square roots of that stuff. These 2's are going to cancel, so we're left with x plus 1 over the square root of x squared plus 2x minus 1. Number 6 and 7 can be a little bit tricky. And what we have to do is find out what the function is and what the x value is. So let's look and see if we can find what f of x is equal to and what x value we're trying to evaluate the derivative at. The definition of the derivative, the limit as h goes to 0, f of x plus h minus f of x all over h. Well then what did we do? What x value did we plug in and add h to? We plugged in an x value of 4 and added h to it. So our x value is 4. And then what did we do to 4 to get 4 plus h and the square root of it minus 2? Well, we took the square root of it, because here the square root of 4 is 2. Or we can think about the square root of 4 plus h. So f of x is equal to the square root of x. It's like a symbol out of Transformers. So now we need to take the derivative of it. So what this question is asking is, using the definition of the derivative, given the definition of the derivative, take the derivative of the square root of x and then evaluate it at 4. So the derivative of the square root of x, f prime of x, is equal to 1 over 2 square roots of x. And then if we evaluate that at 4, we get 1 over 4. So we're going to plug in 4 for x, and 1 over 2 times 2, 1 over 2 times 2 is 1 over 4. I really think that the easiest way to kind of learn these is to just see more and more of them. So again, what is f of x and what is x? always look at what we're adding to h. So we have 1 plus h. So our x value is 1. And then what did we do after we added h to x? We raised that to the sixth. So x to the sixth. So here we would have x plus h to the sixth minus x to the sixth. And if we plugged in 1, we would get 1 plus h to the sixth minus 1, because 1 to the sixth is 1. So take the derivative and then evaluate it at x equals 1. The derivative is 6x to the fifth. And then if we evaluate that at 1, 1 to the fifth is 5 times 6 is 6. Number 9, it looks like it's a little tricky. Take the derivative, and f prime of x is 3. No matter where you are on that line, 3x, the slope is of any point on that line, the tangent line, is going to be 3. So no matter whether we're at 5, 10, 20, whatever we want to evaluate the slope is always the constant 3. Which of the following expressions represents the derivative? Well, even though this is a polynomial and we can use the power rule, all of the answers look like they're in the form of the definition of the derivative. So if we take this and we use the definition of the derivative, the limit as h goes to 0, f of x plus h. So we'll have negative x plus h squared. So I'm plugging in x plus h here. I have to plug in x plus h here. And then we have to subtract the original function. So minus f of x again. Minus negative x squared plus x all over h. So this was f of x plus h. This is f of x. We're subtracting the two, and then we have all over h. So if we look down at our answers, the limit as h goes to 0, so maybe it could be a, but we don't just add h at the end, we have to add h to each individual term. So we'd have to add h here and add h here, so it's not a. B, this is the limit as h goes to x, so not h goes to 0. Here we don't even have a limit involved at all. The limit as h goes to 0, and if we compare our answer, over here, we have negative x plus h squared plus x plus h, and then minus the original f of x. So D. I think when you draw a sketch of the derivative, the points that you really want to try and find are the points where the tangent line is going to be horizontal. So if these are where the tangent line is going to be horizontal, we can come down to the x-axis and make these x-intercepts. And so they seem to be pretty close to negative 1 and 2. They're close enough. Might be a little bit less than negative 1 and a little bit more than 2, but they're pretty close. And now let's think about what our slopes are doing. So here, our slopes are positive. But if I looked at all of these tangent lines, here they're like very positive, and they become less positive. So they're going towards 0. So they're positive but going towards 0. And then there's a point somewhere here in the middle where at first these slopes, sorry, I'm changing colors here. At first these slopes are becoming increasingly negative, so they're going down. And then at this point, they start becoming like less negative and going back towards 0. So they're going to have to turn around and come back up to 0. Notice that these are all still negative, but it's just that in the purple part, they're becoming increasingly negative, and then in the light blue part, they're going back to 0 because they're going to flatten out here. And then after this point, these slopes are positive, and those slopes are getting increasingly steeper, so they're becoming more positive. Again, let's look for the point in B where our tangent line is going to be horizontal. So our tangent line is going to be horizontal probably somewhere around there. And then on the left side of that, we have positive slopes, but they're going towards zero. They're flattening out towards zero. So we have positive slopes that are flattening out towards zero. We become zero right here. And then on the other side, we have positive slopes that are becoming increasingly positive. There should be no points on the derivative that are below the x-axis, because at nowhere on this curve is the slope negative. The slope is positive but going towards zero, becomes zero, and then positive going away from zero because those slopes are becoming steeper. The average rate of change is f of b minus f of a all over b minus a. So we need to plug in 5 for x. We get 25 minus 15 is 10. Plug in 2. 4 minus 6 is negative 2. All over 3, which is 12 over 3, or 4. We now want to use the definition of the derivative, and I'm just, for my sake, because I don't want to have to keep scrolling up, f of x is equal to x squared minus 3x. I'm going to come right down to the wire here. I'm wasting time. Okay, so using the definition of the derivative, the limit as h goes to 0 of f of x plus h. So everywhere I see an x, let's plug in an x plus h. X plus h squared minus 3 times x plus h minus the original function, x squared minus 3x all over h. So now if we do out some algebra, we get x squared plus 2xh plus h squared minus 3x minus 3h. Distribute through this negative sign, minus x squared plus 3x all over h. Let's cancel out things that we can. And we're left, everything in the numerator now has an h. So in the numerator, we have h times 2x plus h minus 3. So I factored out an x from here, here, and here, all over h. These now cancel, and we can say that f prime of x is equal to 2x minus 3, because we're going to plug in 0 for this h. Now that you have the derivative, you can plug in 5 for x. So I have an equation for the derivative in 2x minus 3. I can plug in 5 and I get that the derivative at that point is 7. The two things that we need to write the equation of a line are a point and a slope. So the point that we're trying to do this, if x is equal to 5 and it's on the function f of x, we found that in part A. The point was 5 comma 10. So we plugged in 5 for x and got back 10. The slope of the tangent line, which we found in part C by using the derivative, is 7. Using point slope form, y minus 10 is equal to 7 x minus 5. Alright, so that's this review sheet, and I'm coming right up on 15 minutes. So I hope this helps. If you have any more questions, let me know. See you guys tomorrow.